Good morning, good afternoon, and good evening. Welcome to the ITU AI and Machine Learning 5G Challenge webinar series. My name is Thomas Backhaul from the ITU, and it is my privilege to introduce today's webinar. The AI and Machine Learning 5G Challenge is organized by the ITU, which is United Nations Agency for ICTs. The mandate of the ITU is to allocate frequencies to services that uses the radio spectrum, to develop standards, and to assist developing countries in setting up their ICT infrastructure. The challenge is kindly sponsored by Xilinx, and we are grateful for their sponsorship. Furthermore, the challenge aims to create a community that will solve network-related problems using AI and machine learning. Now it's time for me to introduce today's speaker. Today's webinar is going to be given by Evren Tuner. Evren has nearly 8 years of experience in telecommunication industry. He has worked in positions related to the core domain in both mobile and fixed network at Turell. He currently works as a 5G R&D expert at Turell 5G R&D team in Istanbul. He is pursuing a PhD in electrical and electronics engineering at Baskhill University in Istanbul, Turkey, with a thesis on recurrent neural networks, assisted network slicing in 5G and beyond networks. He received both his BSc and MSc degrees in electronics and communication engineering from Azmir Institute of Technology. His research interests include artificial intelligence, 5G and beyond networks, network slicing, edge computing, and private networks. In today's talk, he will introduce problem statement number 12, radio link failure prediction. In telecommunications, weather-related phenomena affect the performance of radio links. This is especially applicable to backhaul links that operate in gigahertz frequencies. And in this talk, the aim is to introduce this problem statement, and the data set that is going to be introduced is a regional-wise data that was compiled and is anonymized, which corresponds to weather forecast, radio link performances, and radio link failures that is derived from a network. Given this regional-wise historic data set that is derived from a real network and the weather forecast from the meteorological stations, participants are expected to predict the occurrence of radio link failures first in the next day and next in the following 10 days. So I would like to welcome Evren. Good afternoon.
Hello everyone again. This is Evren Tuna from Turkcell, and I'm very happy to see a lot of people dealing with telco AI domain from all around the world. First, I would like to thank ITU for organizing this challenge, and we are very happy to be participated in this challenge also. Actually, I would like to start with why actually Turkcell is focusing on autonomous networks. Especially with the 5G and beyond communication networks, we are facing a more complicated structure where different technologies and different techniques such as edge computing, network slicing, virtualization, and software defined networks are integrated, and the network complexity is increasing gradually. And at the same time, mobile communication networks are now focused on serving very different verticals. And although its applications in the field of computer science are advanced, we can say that the AI applications in mobile communication networks are relatively behind. Because, as we all aware of that, because in a live network, the reliability of an AI algorithm must be ensured to a certain extent. So we think that a more scalable, flexible, and adaptable network will be achieved by AI algorithms. So before going into details of our problem description, I would like to start with a brief introduction of Turkcell. So let's start. As you can see here, Turkcell is a mobile and fixed line operator. Especially for the last decade, the technological developments forced operators to transform themselves from a traditional service provider to a more digitalized manner. So as Turkcell, we are transforming ourselves. Actually, we have transformed from a typical network operator to an experience provider. For this, we are developing new digital applications and services, such as here you can see BIP, Yani, TV Plus, Fizi, Livebox, etc. Thus, we can say that Turkcell now is a digital operator. If you look at the statistical information, moreover, we have more than 50 million subscribers in 5 countries. And as I mentioned about our digital services, we have nearly 180 million digital services downloads globally. And we have nearly 86 million digital subscribers globally. And as Turkcell, we are listed on New York Stock Exchange with a 5 billion market cap. If you look at our R&D activities and R&D projects, we can say that we are very active on R&D area. Turkcell has nearly 1,000 R&D engineers, but most of them are working for development of our digital services. So we can say that this R&D is related to software developing part. But as Turkcell, we are also focusing on future communication R&D activities, such as you can see our R&D focus areas like AI, ML in telco, cellular V2X, network slicing, and other ones. But we are really focusing on the AI and ML applications in telco domain. By applying these algorithms, we are targeting to achieve self-optimizing networks and network automations in varying parts of our network. And also, we have now actively working on 15 R&D projects, and these R&D projects are funded by Horizon 2020, TÜBİTAK, our national funding agency, and Celtic put next. So these numbers belong to my team and future technologies of R&D department. So we have also started our operations in 2017. So these are our activities belonging to this. And also, we are also actively contributing to standards development organizations also. And we are actively participating ITUT study group 13, here you can see. To be more specific, we are working in focus group on autonomous networks and technologies for network 2030. And also, we are following the activities of RAN 2, which specifies the radio interface architecture and protocols for UTRA and beyond. And Turkcell is a member of 3GPP since 2018. And if you look at the GSMA also, we are the member of board of directors there. And we are also participating in GMN as a trial and test initiative pre-commercial network trials co-lead operator for 5G. And we are also members for 5G PPP, Telecom Infra Project, and Open Network Foundation. And for Open Network Foundation, we are collaborating as an innovator of ONF working RE and MCORD platforms. So let me talk about our problem that we addressed during this challenge. Actually, if there exists anyone from the last year's challenge, most probably you are familiar with the problem. And last year, Dr. Salih Ergut has presented the challenge on behalf of Turkcell, and now he has also contributed to the modified version of this new problem. So as operators, we are deploying a lot of systems for radio network, transport network, and core network. So as Turkcell, we are managing a huge network. I mean, just for the radio network, I mean the base stations, we have tens of thousands of base stations. These base stations operate in 3G, 2G, and LTE networks. Actually, we don't have fully fiber infrastructure connections for this base station. So we have in certain regions, we have to use some radio links that connect multiple sites together and aggregate their traffic to our core network. And especially for the varying weather conditions, these radio links, as you can see the radio links, are susceptible to the changes in the weather. And these weather conditions include cloud, rain, snow, and other weather-related phenomena affect the performance of our radio links. And this is especially applicable to backhaul links operating in gigahertz frequencies. I mean, the frequencies between 7 to 38 gigahertz frequency. So this kind of weather-related phenomena disrupts the line of sight communications especially. So, and as you know, these sites are located in monopoles or towers, as you can see from the picture. For example, a very strong wind may sometimes makes these sites move a little bit, I mean the radio link, and the tilts may be lost. So as a result of this, you may lost your line of sight communication. So this is the general view of our problem background. And also, if you look at the literature, yeah, we can see a lot of research about this problem. One of these is actually a survey on network resiliency methodologies against weather-based disruptions. Here, this study considers different radio link problems that are affected by the weather conditions. And in this survey, they classified and discussed the relevant studies, and they proposed some methods against the weather-based disruptions. And this paper also investigates the dynamic property of a tropical forested channel due to the weather effect. I mean, they are dealing with the very high frequency and ultra high frequency wave propagation. And this paper focuses on the analysis of the combined effect of wind and rain, which is often encountered in tropical forest areas, as you can see. And if you search on the literature, you can also find other studies related to this problem. But I would like to go on with our problem now. So from operational point of view, we can say we are monitoring the values of KPI related to our radio links directly from our KPI monitoring systems. And additionally, we are also monitoring the weather reports that is gathered from our National Meteorology Authority. So here we can say that in our problem, we have two types of data sets. The first one is weather report data set, and the other one is radio link KPI data set. So here, when you download the data set, here you can see that this data is at daily periods, we can say. So here the challenge is to predict the unavailed second and BBE KPIs. I will give the details of these KPIs in the next slides. And our aim is to, as Thomas in the beginning of this webinar, he stated that we are trying to predict the next day and the radio link failures any day in the next following 5 days. So the action part here, as you can see, which is not related to this challenge, but I would like to inform you what kind of actions we take in such failure situations as an operator. Of course, it depends on what the problem is, but we take some hardware and software-based actions here. For example, suppose that it is not a hardware-based problem, but yeah, we can see that there is a line of sight problem in signaling at the air interface. In such cases, we make a change of location. Thus, by doing this, we fix the line of sight problem after the change. Actually, for more complex problems, we change the direction of our radio links to another site also. And most probably, the hardware-based problems are directly related to physical characteristics of hardware. Here, our most important action is hardware change. So as a result, we saw such problems with the support of an expert or any technician in this site, either remotely or on site. So in our problem, we will not fix this radio link failure after it happens. By the prediction, as a result of this challenge, we are planning to take actions for a possible failure. So you can see from the prediction data set, the predictions are here made in twice a day. I mean, the morning predictions you can see in the data set, and also you can see the evening predictions. So if we go to details of our problem, I mean the data set, we have a region-wise historical data set. And here in this data set, we have some KPIs of radio links and other weather stations KPIs. So we can say that these are especially for the radio links KPIs, these are the performance indicators of these radio links. And then also, once we have the relevant weather conditions, we aim to predict how radio link will perform, if we are gonna see any failures or not. So if we look at the details of dataset, we can see the training data includes pre-processed and anonymized radio link KPIs from our commercial networks and time-aligned weather data. And we have KPI data and the information of date and time also. So we have a frequency band information, link length, error and failure statistics, availability ratio, and stability score, capacity and modulation types such as 128 QAM and something like that. So as for the weather forecast, we have two sets of data. One of them is forecast. Forecast data includes status, temperatures, humidity, wind, speed, and direction for the following 5 days. It's, as I mentioned, it is recorded twice a day. And the other one is the measurement data and actual realization of those forecasts also. And we have also measurement data that includes the temperatures, wind speed, direction, precipitation, and overcast, which are recorded hourly. And we have a distance matrix also. And we have a matrix, as I will mention detailed in by checking the data set. We have a matrix that gives the distance for weather stations and radio link sites. I would like to talk a little bit about the download process before going into the details to the KPIs. When we download and open the zip file, we will see two files, an Excel file and a zip file. To be able to view the region A Excel file, this is an exemplary data set. It contains some KPIs here. When you open this, you can see the KPIs. Our main file is region A.zip file, and this file contains the following TSYS files. We have included all these details as a README file .out, and how we will follow path when we download the data cluster from the link we have given. So, and also, moreover, apart from this, as an additional information, we have mentioned some details about the dropping some columns of this dataset. I mean, for RL KPIs, any ID, direction, polarization, and link length, scalability score columns are omitted because we saw that there exists too many null elements, so we have dropped these elements, and so you will have the final version of this dataset when you download. Here, as you can see, if you look at the radio link KPIs, we have radio link equipment vendor type. The first one is this. The other one is, of course, we have date and timestamps of these data. And also we have another KPI as endpoint. This denotes to link endpoint, which can be near or far. And also we have MLID, which means that mini link ID, and we have also MW connection number. This KPI denotes the unique internal connection ID. We have site number, site ID. Here, as you can see, the polarization. This is one of the most important KPI in our operations. It denotes the radio link antenna polarization, which is vertical or horizontal. And we have card type. We have the adaptive modulation type. In some radio links, we have activated the adaptive modulation. And we have the operating frequency band also. We have the link length that denotes the distance between two sites. I mean the line of sites, two sites, let's say. And severely error second, the count of 1 second periods with error that covers percentage 30 less than percentage of the frame. And also, as I mentioned, we are aimed to predict the unavailable second, which is radio link unavailable operation duration in seconds. And also we have BBE, which indicates the performance degradation. And we can say that this is the background bit error count. And also for the legends, we have for RL sites we have site numbers. Each different site number denotes different radio links operating in our network. We have site IDs also, and we have clutter class. And for the weather stations here, MET stations denotes the weather stations. We have weather station number and clutter class. And we can see also in the distance part, distance sheet in the Excel, you can see the radio link site and weather station number. So for submissions, firstly, we expect to obtain the predictions in a CSV format. This is a baseline submission requirement. And moreover, the data set that we shared should be used for training. And it is also important to state that why a specific type of machine learning model is chosen. And you should clearly explain what are the advantages and disadvantages of your model. And of course, we would like to obtain design documentation and the related documented code. For example, suppose that you are using a recurrent neural network to solve such a problem. We are expecting that what is this neural network model and how many layers you used, what kind of hyperparameters did you use, why did you use such hyperparameters, and what kind of actions did you take for hyperparameter tuning, etc. So as you can see, to sum up, you need to present your approach, your solution type, and your results. And here also, as you can see, our evaluation criteria. Firstly, the participant must use the provided data set to train a machine learning algorithm. Secondly, the output of the machine learning algorithm should be able to predict the performance obtained in a new network deployment. I mean, we will provide and also a test set. Then the choice of the machine learning approach is decided by each participant. Moreover, a test data set, as I mentioned, will be provided to evaluate the performance of the proposed algorithms. And also the evaluation of the proposed algorithms will be based on the average squared root error obtained along with the all predictions compared to the actual results in each algorithm deployment. So finally, the winners will be given prizes and may be invited to publish the results in an academic publication or present in a conference or something in a dissemination activity like that. So here you can see the Turell challenge team. You can contact any of my colleagues in Turell challenge team. And as I mentioned from last year's challenge, Salih has also some contributions to this challenge. And here you can see İlker and Ismail. They have deep expertise in access transport network domain, and they are working as an access transport network strategic planning and operations planning expert. Semi has an expertise in also data science and AI and working as an R&D engineer. And as I mentioned, I am from 5G and 5G R&D team in Turkcell. So you can contact for any of your questions. Actually, this is all for my presentation. But before going into the question and answer, I would like to also show the details of our exemplary dataset, Thomas. So here, as you can see, as I mentioned, we have a matrix. This is called a distance matrix. Here you can see the weather stations, which are denoted by WS. and also you can see the radio link sites. So these numbers denote the distance between these weather stations and radio links, or radio links to radio links, and vice versa. So in a typical environment, I mean, today we are monitoring the, for example, for a radio link site, we are taking the closest weather station, or we are taking the three of our weather stations that are closest to this radio link, and we start to analyze what are the KPIs related to this weather station and radio link, etc. So we can see also the radio link sites sheet. Here we have also classified the radio links operating class as open land, dense tree, open land, or etc. And you can see the radio link KPIs here. You can see the KPIs that I mentioned in previous slides. And we have a forecast of this weather station data. And here you can see the report times exist twice a day. In evening and morning forecast exist. And we have also the actual, let's say, the actual values of these weather stations. And we have also classified these weather stations as it's operating in a dense tree, airport, something like this. So, Thomas, that's all for my presentation. I think we can take some question and answer part.
Thank you so much, Evren, for the nice presentation. It is quite interesting to see this problem statement. We had a different version last year. I see that you have improved on the version. You have changed some of the information related to this problem statement for this year, and we are happy to have Turell as part of the challenge. Now it's time for the Q&A, so I would like to invite my colleague Vishnu. Welcome, Vishnu, and good evening.
Hi, Thomas. Thank you. And thanks, Evren. It was an excellent talk. I remember last year's challenge. Sari is my great colleague, and thank you for coming back again this year. I remember you and the colleagues, Semi and the colleagues were involved last year as well. So yeah, I remember. So thank you so much for coming back. Just a couple of questions from my side. I think how has the data changed from last year to this year? This is very interesting for us because I think Turell has been very progressive in, it is a pioneer in putting this kind of real network data for this challenge. And it has come back with again another version of a similar challenge. For me, it is very exciting because it is moving forward in the same lines. So you are making progress in the same problem statement. So I think it is definitely very exciting for me. So that's why I'm asking how the data has changed from last year to this year, please.
Yeah, actually, it seems like, yeah, we are having nearly similar problem with the last year's challenge, but this time our proof of the area that we consider has been changed. Now, I mean, we have considered a different radio access area. So most probably the change in this considered area will affect the results, and we will most probably you will have the different trends on the traffic. I mean, I can say that we have considered an area that has more crowded than the previous one. And also, again, our prediction aim is similar, but this time we are expecting to get the prediction results that indicates any radio link failures within the next 5 days. We are expecting that, yeah, you may have I mean, 6 radio link failures within the next 5 days. Now, the this time the region that we consider has changed, and also the prediction aim has been changed. And also when you analyze the data set, you will see the differences between the KPI trends also as a result of this different region.
Thank you.
Can I also add a few points here, Vishnu?
Yes,
Yeah.
yes, please.
Hello, everybody. Thanks for your kind words, Vishnu. I'm sure this is going to be another exciting challenge. Something we observed from last year was there were some missing values in the regions that we collected data. For that reason, it was difficult to apply any the time series data. So you may not have enough the samples that are not interrupted. So this one is actually specially picked so that it has very few null values. So it's very more suitable for time series implementation in that respect. And the data itself is more clear, clean when compared to the last year's data, especially based on the feedback we received from the participants. Many things are resolved in that respect. So hopefully, this would be more exciting in that respect. And as Evren mentioned, this belongs to a newer region, more crowded. So there are newer challenges in the data as well.
Thank you, Salih, and nice to see you again. So I want to ask. So everyone was saying earlier, right? You have taken more of looks like densely populated areas and maybe urban areas, maybe, and has the number of sites increased? Has the diversity changed, or has the number of weather stations that you pick up now has increased or changed? This is very important, very exciting for me, because as you're saying, you have now improved the quality of data, right? So you have basically raised the bar on the quality of data. This is very exciting for us. In my personal opinion, this is what really matters. It allows the participant also to raise the bar, right? So that's why I'm asking, what kind of increments have you done in terms of number of radio link sites and the number of weather stations and the type of the sites?
Yeah, actually, the type of the operating area, this time we have more radio links operating in an urban, the suburban or the city center based radio links. And also, actually, I didn't check the exact numbers of previous and today's radio links number, but we can say that this is a typical mostly crowded area. We have more base stations to deploy there in order to cover the mobility, fast mobility changes during the day. So we have more radio links in such kind of a place.
Very good. Thank you so much. Actually, there is a question which was in my mind also. Murali is asking, can you list specific actions? So you in this slide, you are talking about hardware. In fact, you already mentioned that orientation of the antenna and the hardware changes and the technician visits, right?
Yeah.
Everyone, you were talking about the technician visits, and that's what you would like to plan and so on. So the question is, what exactly are the specific actions that you would like to take? I know that these days operators look like site examination using fancy techniques, like I have seen technicians here using drones and so on. Would you do something like that, or would you use some remote tools, or would you really have to drive down there and do something? The technician somebody has to really drive down there and do something. What are the specific actions that you do? And also, I think another question related what I had was, would you plan the technician visits based on these predictions?
Actually, as I mentioned, on behalf of this challenge, we are just expecting to get the prediction results. I have just mentioned about our actions because of just giving brief information from the communication network operator point of view. So if I tell again, by using these prediction results, or today as traditionally we are monitoring in a periodical manner, but when we have a radio link failure in a certain base station, we, after the examination of this problem, generally we took some actions which is related to hardware or software, and most probably we take hardware based actions. For example, suppose that there is a line of sight problem. I mean the signaling at the air interface between two radio links. In such cases, we let a technician to go to the site and make some changes. These changes he or she can replace the equipment, or he can fix the he can fix the radio link placement or anything like that. The aim is just making the two radio links to facing each other, right? So of course, when we today as traditional manner, we are taking actions after the radio link failures, right? So we aim to predict this radio link failure and get some precautions before the radio link failures. So when we get the prediction results, of course, we will verify these prediction results with actual results, and we will also develop our precaution requirements in our site also. So we can say that, yeah, by using this prediction, our aims is to get precautions just before the radio link failures.
May I also add a few points here? So there could be also like some configuration changes, say like the modulation types and etc. as well. As Evren stated, like the technicians would go to the specific sites and then resolve any problems that may occur. There's also an additional benefit of this type of estimation. Basically, once you have like the certain weather conditions and whether that's going to cause a radio link failure is valuable for the operator, because then you can identify risk of your existing radio links. So even before a harsh weather, you can prioritize which links to take care and then do some actions based on the predictions that you may have, the predictions that you have for radio link failures in case of a harsh weather and etc.
Thank you, Salih. Thank you, Evren. I think there are a couple of more questions. In fact, actually another one which I had in my notes also about collection of data from weather stations. Now, I remember discussing this with Salih last year also, but I don't remember his answer now. I think I was asking him how he collects the data. So I think it looks to me that it is a mechanical process, right? You basically get the weather station data, a dump of it, maybe from maybe the weather station publishes it, or you have some interface where you get the public data from the weather station and pre-process it. I don't remember now. So could you tell me again, how do you get this data from the weather station? Is it public data? Is it in a machine readable format, or is it in a human readable format, which you pre-process and make it available for the participant? And then the question is whether there is, or I guess it is automated interface is possible with the weather stations.
Actually, for the radio link sites data, you may guess that we are gathering this data set from the tools that we have created which belongs to the vendor type, right? So, but for the weather reports, let's say weather report data set, we are using the data that is provided by our national meteorology agency, let's say. So we have also another a different tool for gathering the data from this weather. I mean our national meteorology agency. So for each one of these data sets, we are using some tools that is private to Turkcell or any other operators that has some I mean the requests rights onto this tool. So we actually we are using some tools to gather this data from the live network or the weather live weather data set, let's say.
Vishnu, as Evren stated, this is like the third party, and we have integrated into our database. So that's where we are actually providing the data. In many of third parties, you can have the historical data, but you may not, you wouldn't have the historical forecasts. Like the forecasts are only available for live data. One advantage we have here is we are also recording the forecasts that the weather stations had for the following 5 days. So in the historic data, you have both like the realizations and then the forecasts. So you can use that in your model. But the structure of forecasts is a bit different than the realizations. So that is also tricky to use both of them in your network. So I think that's another challenge that the participants should be aware of.
Yeah, I remember Semi explaining this last year. Yeah, thank you. I want to ask another question, which is here: is link budget available for different fading channels, or is it fixed link budget? I don't know. Evan, would you like to comment?
Actually, could you please repeat the question a little bit?
Question is link budget available for different fading channels? I guess the question is about radio propagation channels, and the question is on link budget, whether it is available for different fading channels, or do you assume it to be fixed?
Maybe I can have a comment here. Like the KPIs that we are collecting from the radio link sites are daily KPIs. So you don't get to see the instantaneous power changes over the RF link. So it is more like aggregate statistics, and you wouldn't need the link budget in that respect. And the weather stations, the data is actually, I mentioned for the forecast, it's like for the daily for the next 5 days, and realizations, those are like hourly statistics. So in that respect, like the KPIs only are available on a daily basis, aggregated over 24 hours.
Thank you, Sally, and thank you, Evren. I want to discuss another aspect which we also touched upon last year. I think we discussed about topography, maybe not. So my question is about topography. So, you know, the paper that you mentioned, you know, Professor Lee's paper, that has reference to foliage and you know, the conditions, yeah, right there. So how does this matter? I mean, the topography that you have, the kind of topography that you have, the vegetation that you have, the buildings and the obstructions that you have, does it matter here in your data set or not? First question. Second question is, I know that here you are looking at more of a, mounted antenna, right? So here maybe I'm thinking you may be really above such topographic limitations. So maybe when you generalize to other geographies, would that matter? And the third part of my question is, we definitely discussed with Sally last year. There is generalization aspect. So the question is that if, let us say, we try to generalize this in the context of another operator, like China Mobile or somebody like that, some operator. So if you look at such a different geography, would the solutions that we come up with generalize or not? Those are the questions. Could you comment, please?
Thank you for the question. Actually, as an operator, we are deploying tens of thousands of base stations all around to Turkey, and in each different regions we have different geography, different climate, etc. So our planning experts, I mean our network planning engineers, are designing the deployment criteria by considering these such kind of the climate, the geography, or etc. But especially for the city centers, I mean, as we know, these kind of areas can change dynamically from a month to another month. I mean, for example, we are facing such a problem, like some constructions exist after the deployment of this area. I mean the deployment of this base station, and especially for the rural parts, especially we are having problems related to weather phenomena also. Of course, maybe, I mean, actually you can design your model to an operator base, but when you apply to this model to a specific region, I mean a specific region that an operator serves, you may get different results also, because the traffic trend and the change of the region may differ while with the concentration of other regions, right? So actually we have the generalization. I mean, we have to address the generalization part also in this challenge. But actually, it may depend on the region that you consider. I mean, because in each different region, your deployment process differs from the other regions. So I hope that I can explain.
Maybe I can also add a few points here. Like the models that are going to be developed are going to be a function of the RF, like the KPIs, RF statistics, configurations, and weather information. And then the equipment that we are using are also very similar in many other networks, both in Turkey and say like in China Mobile, China Unicom, and etc. Or if you go to Europe, another operator. So in that respect, we think it has a great potential to be generalized. Maybe it may need to be tuned with a small amount of data using like the transfer learning or something like that. And with respect to your question about the foliage or the buildings, whether if they have an impact on the data set, we are not considering it as an input. So we do not have any topographical information other than like the height of the sites or like the radio sites or weather station sites, but it's not enough to give information about like whether it's a rural area or there are buildings around or any foliage. But when we have like what we would like to see is to estimate the radio link failures with respect to these input parameters that I mentioned. And so when a site engineer identifies a risk on a link, he will have a site visit, and then he can take into account of like additional improvements based on the topographical information that he observes. So it's not as part of this challenge to use that topographic information, but that can be used in the action part when you have a good running working model. And we believe it can be generalized into other regions or other operators.
Thank you, Sari. Thank you, everyone. I think those are good answers. Can I, Sari, while you are here, can I please ask you to answer this question about David is asking about ITUR, SG3, database of measurements, and basically references, and also about propagation prediction. You see the question. Could you please take that question also, please?
Sure. I mean, so I'm not very familiar with the details, but what I see is it's more about like the instantaneous link related parameters. If it is so, then it may not apply for this challenge. But I mean, this is the good part of this documentation. It's a draft in the sense that when we are actually proposing the challenge, if you could point us the relevant specifications, we are going to be very happy to include as references. Like one thing we may actually emphasize here is like the radio link failure is not defined in the standards. So that was one of the problems we had. Every operator has their own specification of how you define your radio link failures. So that part may need to be modified from one operator to another. So in that respect, if you are missing anything, if there are any specifications that we have not figured out, that would be also very useful for us to give reference. But in short, we would be very happy to include any references that you think relevant to this challenge as well.
Thank you. Data sets. Yes. So everyone explained the data sets. Question, I guess, is that there are several people who are very excited about it, would like to start tonight. So when is it available? Is it already downloadable? Can I click somewhere?
Actually, we have shared this data set by using our cloud service. I mean, the Livebox link you can download by using this link. But actually, in the next, most probably in the next week, we will have also shared this data set in the GitHub also. Now it's available. You can download, but we will also change the platform to GitHub also.
Thank you.
On that question, Vishnu, I just wanted to add something. So people are asking, is the challenge available, the dataset available? We are in the final steps of making the platform available where you can access all the problem statements. You can access all the datasets at one point in one central location. We will share the details probably next week if all goes well, but we are in the final steps of making this platform available for participants to start registering, working on their models as well as the solutions. So just keep on checking on our website, your emails. We are going to share the information very soon. Thank you.
All right, guys, hold your horses. I guess that's what Thomas means. So please look out, and we will give the links very soon. Do we need to consider construction condition between pair of radio stations? I guess this is Koshimitsu-san. This is what we discussed about topography. Is there anything to add here, everyone? Please.
Actually, there's nothing additional to add more. That's all, I think.
Okay, thank you so much. This is not a weather condition. It's not possible to forecast obstruction between these stations. I guess the question Koshim is asking is other than weather. I mean, of course, you can use weather data, but I guess the question is, can you predict other kinds of radio link failures from this kind of data? I guess that's the question.
Actually, for our operations, let's say for Turkcell's operations, Turkcell is analyzing the radio link failures by using the weather forecast data set, and also by directly gathering the KPIs of these radio links. And for our operations, we consider the KPIs, the unavailability and the BBE as the KPIs that denote the probability of any radio link failures. But of course, this can be changed from an operator to another operator. But for our Turkcell, we are using these two KPIs threshold as, if the value is below this threshold, we can most probably have the radio link failures or not. I mean, the unavailability of these radio links, we have some threshold, some predefined threshold in the system. So any unavailability value upper or below this threshold, we can say that this is failure or not. It is up to design of the network designs, let's say. It's up to your design, your network design. So as Turkcell, we are considering these KPIs.
Thank you. I think we are slowly coming out of time. I want to ask just a small curious question about the matrix. So if you don't mind, the matrix distance, is it in what unit? I mean, is it in miles, kilometers? What if that is not confidential?
Actually, when you gather a weather data set from the meteorology agency, you have some weather stations, as you can see also in the dataset Excel file. But when we merge these weather stations with our related radio links, we use the distance metrics. I mean, for example, we know the location of a specific radio link, and we know the weather stations around this radio link. So by using some distance threshold, we consider the weather stations that are closest than others, let's say. So if you would like to use the weather station data, you should define a threshold for the distance of weather station between the weather station and the radio link sites. You may use, in order to use these weather stations, you should use the distance metric.
Because Evren, the question is that, is it in what unit? Is it in Euclidean distance? Is it straight distance, or is it what kind of distance is it? Is it
actually we have, silent.
No, just like, I mean, just the locations, the coordinates between those 2 points, it's like the Euclidean distance between those.
Okay. Yeah, thank you. Then I think we are closing. We would like to thank you again, Evren and Sally. It's a great collaboration. We must have done something good last time, because you guys are here back again. so thank you so much for coming back and offering this problem statement and data for us. Thank you for answering the questions. Back to you, Thomas.
Thank you so much, Vishnu, for the Q&A. And at this moment of time, I would like to give a very big appreciation to our speaker, Evren, as well as to Sally for the wonderful talk, introducing the problem statement 12 on radio link failure prediction. We did appreciate for Texel to come back this year with new data sets and from real network. We are very happy to have you around, and we hope that more participants are going to join this problem statement and you are going to have interesting solutions. I would also like to take this time to thank everyone who participated or who attended today's episode in the webinar series that is brought to you by the AI and Machine and 5G Challenge. So please make sure that you check our events on the AI for Good event page. And we are looking forward to see you in the next episode that is coming to you next week on the 24th. From me and my colleagues at the ITU AI and Machine and 5G Challenge, I would like to wish you a very good day and bye-bye.